take a look at this satellite image of Earth's surface. If you look carefully at the continents, you might notice something which many have noticed in the past, and that is that the continents almost look like they fit together, kind of like the pieces of some sort of giant, massive puzzle. Of course, you probably noticed this the very first time you saw a map of the Earth or a globe while a child in school. The place on the Earth where this is most obvious is along the eastern coast of South America and the western coast of Africa. Here, it really appears like the continents fit together. Now, of course, people have known this for hundreds of years, ever since the first accurate maps were created. But most people just chalked it up to mere coincidence. One person who had trouble with that, though, was German meteorologist Alfred Wegener. You see, Wegener couldn't just accept that this was a coincidence and that these landmasses had such similar shaped coastlines. And so he began to think about this and try and come up with some sort of explanation. And what he concluded was something radical, that the continents are moving. And in Wegener's head, if the continents are in fact moving, and you run time backwards, there must have been a time when all of those continents were together in some sort of supercontinent, something he named Pangaea, coming from the Greek term for all Earth. This became known as Wegener's theory of continental drift. Now, Wegener, being a man of science, knew that if his theory was going to gain any traction, he needed to provide evidence. And so he set to his life's work of researching every corner of the planet to better understand this strange observation and to explain it to the scientific community. By the end of his life, he had collected 4 main pieces of evidence, and we're going to look at those today. We'll begin where we've already begun, and that is with this shape of the continents. If we look carefully all over the Earth, coastlines appear to fit together, like this part of South America and this part of Africa. And so that becomes evidence number 1, the apparent fit of the continents, that the coastlines appear to fit together like the pieces of some sort of giant puzzle. But of course, this was just a starting point, and so Wegener continued his research. The next thing he dove into involved life. Wegener began to study fossils of ancient creatures, and more importantly, where those fossils were located. Take, for instance, this creature, an ancient freshwater reptile called a Mesosaurus. Interestingly, if you look on all of the continents and land masses of Earth, fossils of the Mesosaurus are only found in 2 places. These include the very southern tip of South America and the southern tip of Africa. Now let's think about this. How could this be possible? We know the Mesosaurus could not have evolved in one location and then traveled to the other. It was a freshwater reptile and therefore could never make the journey through the salty Atlantic Ocean. And so that idea is out the window. Another idea is that perhaps the same exact creature evolved in the same exact way at the same exact time in 2 locations that are separated by thousands of miles. But to Wegener, that was unlikely, if not impossible. And so what he concluded was that during the days when the Mesosaurus thrived, Africa and South America were not separated by an ocean, but rather they were connected as one landmass where the Mesosaurus could roam free. And then at some point later on, those landmasses with the remains of the Mesosaurus were ripped apart and separated by the ocean as we see today. Now, this seemed like a radical idea to Wegener until he began to look at other species of living organisms from the time. And what he found was much the same. There were all sorts of creatures beyond the Mesosaurus, like the Cynonathus and Glossoterus and Lystrosaurus, who all showed very similar, unique fossil distributions, as seen here. And strangely enough, if you reassemble the continents according to their shapes, the distribution of the fossils makes perfect sense. And so this becomes piece of evidence number 2, fossil correlation, or the matching up of similar fossils found in distant locations. At this point, Wegener is excited because his theory is coming together and his ideas seem to have a lot of support. And so he set off to find even more evidence. And he did so by studying geology, or rock structures. Very similar to what he saw with fossil distribution, he saw with rock distribution. In fact, if you look at the mountains of the modern-day northeastern United States, they are the exact type and age of rock found in the mountains of the UK and northern Scandinavia. And so Wegener said to himself, could it be that the same exact rocks formed at the same exact time, but in very different locations? Well, it is possible, but it seems unlikely. And so what Wegener concluded was that those rocks formed at the same time in the same location. And then that area was torn apart by the motion of the continents, carrying those rocks to the distant locations they are in today. And so this becomes evidence number 3, rock and mountain correlation, or the matching up of similar rocks from distant locations, proving that they were once together. And finally, his 4th piece of evidence is probably the most compelling of all, and this involves a look at the past climate of the Earth. So Wegener studied things like glaciers. And what he knew was that when glaciers move over the surface of the Earth, they leave behind evidence in the form of these glacial striations or deep scratches in the rock that show the direction the ice moved as it dragged over the surface. Now, interestingly, if you look at where on Earth we find glacial striations today, they're located in areas like the Amazon rainforest on the equatorial South American continent and the hot, sticky jungles of Central Africa. Now, of course, these are places where you could not find glaciers today, simply because they're too close to the equator and getting sunlight that is too intense and hot, preventing glaciers from forming. And so what Wegener concluded was that these areas were not always near the equator, but rather in the past they were located closer to the poles, where a colder climate could exist and support glaciers. Similarly, Wegener looked at rocks like bituminous coal, which is a sedimentary rock that can be found on the New York State Earth Science reference tables. You can find this table at this link. Bituminous coal is a sedimentary rock that is made from compacted and cemented plant remains. But not just any plant remains, tropical plant remains from hot, sticky, humid jungles. Interestingly, if you look at the major coal deposits on Earth today, they don't fall in hot, humid areas, but rather they fall in frigid areas like northern Asia and Antarctica. So Wegener knew that if this was the observation he was making, this tropical coal being found in frigid places, that those places must not always have been frigid, and maybe in fact they were once located closer to the equator. And so this becomes piece of evidence number 4, paleoclimate data or past climate data, like finding evidence of coal in currently cold areas and evidence of glaciers in currently warm areas. And so these 4 pieces of evidence put together became the theory of continental drift, as published by Wegener in his book, The Origin of Continents and Oceans. Unfortunately, there was one thing that Wegener could never wrap his mind around, and that was what force could be driving the motion of the continents. He couldn't understand how it would be possible for huge land masses to actually move, considering the amount of force and energy required to do so. And without this explanation, his theory of continental drift remains largely rejected in the scientific community. In November of 1930, while on a research expedition on the ice sheets of Greenland, Wegener froze to death. His body was found in the ice months later. You can still visit a cross that marks the site of his death, frozen on the ice sheets of Greenland. The story of Alfred Wegener is a tragic one. It's the story of a great scientific mind who was ahead of his time, but died before he reached his true potential. Modern geologists owe to him their understanding of how the Earth actually works.